Hey, so the next project in this shop is an unusual one, I'll say. Some of you know I've built a CNC router a couple of years ago, and I use it quite a bit. I like it. And I also built a guitar a few years ago, and that was my first guitar, and I kind of fell in love with it. It's a blast. I like making them. The hardest thing, in my opinion, or at least from my first one, is getting the frets cut so that the fret slots cut so that they intonate properly on every fret. Getting the spacing correct and all that. And you can spend a bunch of money on a bunch of jigs, and Stuart McDonald will send you a great big old table saw slitting blade for a couple of $100 or whatever it is. It's expensive. And then you'll also, not only, that'll get you the blade, so the slot has to be 23 thousandths in width, or sometimes a little more, depending on the fret wire used. For the most part, 23 thou is the biggest one, or is the most common one. I guess I could do that, but the other piece you need then is a indexing jig of some kind, so that you can slice one fret, move the fretboard over just enough to slice the second fret, and all of that indexing has to line up. And handily enough, Stuart McDonald will send you and so will Luthier's Mercantile. I'm not harping on Stuart McDonald. I've actually bought a bunch of stuff from them. But there's a lot of specialty jigs where people who don't enjoy making jigs find a lot of value. I like making jigs. I like making mechanical stuff. I like making stuff, not just guitars. I just like tinkering. So I've set out to solve the fret slotting problem myself. One of the other things you need then to do that indexing is they've got Stuart McDonald's and Luthier's Mercantile, and a lot of places you can get these steel plates that are, you know, about 1/16 of an inch thick, maybe 10 gauge, and they have little notches cut in the edges, and the notches are spaced to match the fret distance based on the scale length. And that's the handy thing about audio and instruments, is the distance that the string spans impacts the spacing of the frets. Excuse me. So every time you change that length, it's called the scale length. Every time you change that scale length, the spacing of the frets changes by very small amounts, but it's critical that they're aligned upon proper boundaries, so that when you fret that note, you get that note, rather than you get that note a little sharp or you get that note a little flat. You need it to be that note. So the positioning, I don't know, I've never looked up how tolerant the positioning is, but it's enough to me I know enough about audio and how the change to the length can, even subtle changes can sound very different to a trained ear. And what I'm going for is I want to make guitars that trained ears like to listen to, and hopefully maybe buy someday. But I'm ways out there. So the idea is, the better you can get spacing those frets accurately, the more appropriate, or the more accurately it will create the sounds and the notes that it needs to create. So the idea then is, so for that indexing thing, you have to buy an indexing thing for every scale length that you're going to do. And there's a few common ones, but they're fairly expensive. And you need the sled and the jig, and so there's a little it's like a box joint. There's a little notch in the template. You double stick tape your fretboard to the template, and then you flip it over and you index the steel notched template with a pin and a sled, and that works like a box joint. You cut one, you move it over to the next notch, you cut another, and that's all fine and good. It works well. It's proven technology. It's a little tricky if you need something, like say you decide to build a guitar and you want to experiment with scale lengths. The next option is you mark it off with dividers and hope you get them right, or you cut them by hand, or, you know, there's a bunch of ways. I'm going to try to make make something that is a fairly precision task more complicated than it has ever needed to be. But it's because I like to tinker. And I'm just some guy with a few tools that thinks he likes to build guitars. He's only built one, but I like to build guitars. It was fun. I'd like to get into it more. And I'd also like to make a mechanism or make something to help me make those fret slots accurately and versatile. I want to be able to choose a scale length and space those frets exactly how I want them. I don't want to be limited by whatever template I have, and then you just make a bunch of frets that size. Someday maybe I'll also get into cutting fret slots or fretboards and selling the fretboards themselves. So I want to be able to make repeatable precision fret slots or fretboards. So that's where the CNC comes in. I built a CNC router, and I could, excuse me, and I could just throw in a 23 thou router bit or end mill into the cutter, into the spindle, and just run those slots. The trouble I have is this. So I have this, and let me open it, see if you can even see it. You may not even be able to see this thing. I'm going to leave it, I'm going to try to leave it in the handle. So I don't know if you can see how tiny that thing is, but that is a 23 thousandths end mill. It's pretty tiny. So yeah, I have that 23 thousandths router bit, and it's very, very thin and very flimsy, and it's a homemade CNC router, so it's not, it's accurate and it's pretty sturdy, but those little tiny router bits need very little what they call total indicated runout. I think that's what it's called. TIR. The little tiny router bit, the little tiny end mill, you have to baby it in order to keep it from snapping. It's so easy to snap that thing. And at, I think it was 36 or 32 bucks a piece plus shipping. At that price, I'm not going to be getting into any sort of production runs or any sort of, I'd be surprised to get 3 or maybe 4 ebony fretboards out of it before that bit broke if I was very careful and did a lot of babying. The other part of that then is by babying you have to take really shallow passes, and it can take a while. Not that I'm in any rush, but I'm concerned that I would have to be very, very careful with that bit, and I'm going to break some if I use them. So I started thinking about what to do about that. I still want to use the CNC because I think that gives me the ability to make any spacing I need, and I can tweak it. I can adjust it. I can adjust one fret different if I needed to. For some strange, I don't know why I would, but I would have that ability to do so. So I decided I was going to build something for the CNC to make cutting fret slots a lot easier. And the more I thought about it, you have a spindle that's this direction, right? You have a router spindle that's cutting like this, and you're going to put your board down, and you want to cut these slots, right? Well, it makes your choices for tools pretty limited because, well, you're stuck with a round tool that's really tiny. But what if you can turn that spindle? What if you have, I didn't bring myself enough stuff, but what if you could turn that spindle rotation so that as it turns, it rotates 90 degrees. Now, I'm thinking, I don't know if this is going to work out. We're going to try it. We're going to see, and it may be overcomplicated. And I may do things in a really weird way. But now, because we can turn the spindle 90 degrees, we can put something like a saw in. So, you still got your spindle here, right? And I'll show you the design here in just a second. So I've got my spindle spinning like this, and my saw, I can set some sort of a rig. This is the part I need, is a rig to turn the router sideways. If you turn the whole router over, there are other challenges there. I'd have to build a totally different. So there's a couple of ways. I could turn the router 90 degrees, and I could put slotting saws in there. So let me show you the saws here too. So I got these little 23 thousandths. They're milling machine slitting saws, and I got 5 for, I think it was 16 or 17 bucks. I forget now. Pretty cheap, and they're 23 thou. They've got a 5/8 inch hole, but they're small. They're 2 3/4, I believe it is, diameter, which means most router bodies, or my router spindle body is 3 1/4. So that's already too big. It wouldn't be able to reach a fretboard. So I can't do that. That didn't quite. So turning the router 90 degrees wasn't something that was going to work. You can get bigger ones, but the larger you go in diameter and the smaller in thickness, the thinner you go, the more expensive things start to get, and the more unstable they start to get. A great big, the blade that Stuart McDonald sells you is a 6-inch, I believe, or something around 6 inches, but it's only got the 23 thou right at the edge. It's really thick in the middle, because otherwise that blade's going to wobble at table saw speeds. And so you need it to be stable. So I'm thinking, I grab some small-ish ones, and I'll come up with a way to stiffen even this, and I'll show you that as well. So what I've come up with then is a way to hold one of these saws in a vertical orientation so that I can cut fret slots for as long as my router table, my CNC is about as long as this. It's 60-inch travel. This is a little longer. But then I can cut them as long as I want, and I can go along the entire width, and I can cut full panels of these things if I needed to. Not that I would ever get into a production thing. But the other thing that I think makes, the thing that made me decide this was the way I was going to go, which might seem overcomplicated. I've never seen anybody do this. I've never seen a right angle fixture for a spindle on a CNC router. I've seen them on milling machines. That's kind of where I got the idea. But the second use, I always like to build things. If I'm going to build something, I always like to get multiple use out of it. I like to get more than one value. And I was thinking about, for acoustic guitars, I have a piece of it around here somewhere. For acoustic guitars, there's this supportive material that's put up against the edge of, say you've got your side here, and you got to glue your top or your bottom, your top or your back on like this, and this edge is usually really thin, so there's this, it's called kerfing, that goes up against it, and it fills in that corner and widens that top surface so there's more gluing surface. Well, that kerfing is done with a slitting device of some kind, and then it's a beveled sort of piece. So I thought, well, if I'm doing this, I could put different thickness blades in, or maybe use one of these, and cut full panels of kerfing that I could use for acoustic guitars, or not even just acoustic, for semi-hollow or hollow body guitars. So I thought, okay, there's my second benefit. The third benefit is I like to tinker and I like to make stuff. So that's what really made it send home for me. A lot of people are going to think I'm going way overboard, and it's true, I am. But I like to tinker and I like to make stuff. And I like making mechanical things. So this is kind of a neat trick for me. So let me show you what I've designed. And you'll see it's just kind of a gearbox, a right angle gearbox. It turns the spindle sideways. I'll slow the router way all the way down to, I think it goes down to 10,000 RPMs or 8,000 RPM. And then the gear reduction on this, so I'll show you that too, is going to slow that slitting saw quite a ways down. These things have, I think, a 10,000 or a 12,000 max RPM. Or maybe it's 20. I forget now. It might be 20. But they can go pretty quick. They go faster than a table saw would go. And my belief, and I may be wrong, we're going to find this out together, is that I'll be able to cut these faster, cut frets faster with these without nearly as much babying necessary on a router bit. There's a beep in the background. That's the chat room. Hi guys. Anyway, somebody said my name, and I'll go over there and check it in a second. Anyway, I believe the benefit of this, while overkill and a lot of extra work, and I'm not really saving a lot of money because the StewMac table saw blade is, you know, a couple hundred. I think to get a decent number of the templates, you're probably looking at $300 to $500. I'm in this maybe 100. I don't even think I've gotten that high. Maybe $75. This was like 18. These were 16 or so. The bearings and the materials are fairly cheap. I can get aluminum really cheap. So what I'm going to do, you'll see there's a box. So I'm going to open up the box and I'll show you inside. Now, you'll see inside there's the vertical spindle. I'll show you the gear set here. The whole trick to making this whole thing work is some sort of way to turn a spindle 90 degrees. And I looked around and I looked at, I've looked at those, you could buy drill angle, you know, just 90 degree drill handle. You can just hook a drill motor to it and you can turn your drill bit 90 degrees or a screwdriver bit 90 degrees. I looked at those. Every one of those has, and it makes perfect sense because they're not designed for precision. They have a bunch of play. You can wiggle both spindles around like crazy. So that wasn't going to work for this. These needed to be so precise that I need zero slop in those. And then I looked at a couple of other 90 degree mechanisms. I looked at some actual milling machine 90 degree right angle fixtures, and those might be able to be made to work. The trick was connecting them to a router that takes a 1/2 inch collet or a 1/4 inch collet, and then mounting it to the CNC machine, to my Z-axis carriage somehow. And I looked at them, and the expense of, even on eBay, finding used ones, you never know with the run out, and on those things, they should be fine, and bearings are cheap. So maybe that's a way to go. Maybe somebody would do that. But oh, and the other piece that was missing from those 90 degree fixtures was speed reduction. They were a 1-to-1 most of the time. I didn't see very many. I mean, you can buy, there are 90 degree fixtures out there already that do exactly this, that would work beautifully. They're expensive. I searched like crazy for a couple of weeks just to see what was out there. And there's a bunch of right angle gearboxes. It's not like I'm doing anything new. This is totally reinventing the wheel. But in the end, I decided I like to tinker. I can get aluminum cheap. I've been wanting to turn some of this material before for years. I just finally got some, so I'll talk about that in a bit. And I like making stuff. So now that you've seen inside, you'll see that there's a spindle, and there's a big gear and a small gear. So I decided, after digging around, the two things that turn 90 degrees at pretty good speeds to me were angle grinders, just 4.5 inch angle grinders or 4 inch angle grinders, and hammer drills. Some of the bigger SDS hammer drills have the motor pointing up and then it turns at 90 degrees. So those have a big, nice gear in them. And there were also other gearings. A lot of the milling machines use spiral bevel gears, and so it's a fairly common thing for converting torque. Your car's differential probably has quite a lot of spiral bevel gears for turning, you know, rotary action in an angle in a direction or another. So I decided on, at first, I decided on angle grinders. But then I bought a set. but the big gear was actually larger than the diameter of my small saws, and I had already chosen to these saws. So then I went back to the drawing board and I went looking some more. The angle grinder bevel gear was nice because it meant I could just use a thin shaft all the way along, a fairly thin, not a lot of difference. The ultimate way I ended up going, I have to do something a little different for that, but I ended up with these, and I'll pull in closer, I ended up with these bevel gears from a hammer drill, I think it's a Makita SDS hammer drill. But this will turn my rotary action and it'll gear me down quite a bit. I haven't counted the teeth, so I'm not exactly sure what my gear reduction will be, but there's the gear reductions. So that'll go on a spindle. And today is what we're going to do. We're going to get things ready for that. So I bought some bearings. I'm going to pull you in now. We're going to take this, which is our pinion gear. It's just a simple little 18 millimeter, maybe an 1.5 inches long. So we're going to take this, and we need to turn this diameter down quite a bit because we've got this little bearing. It's a 10 millimeter internal, so we got to put that in there. And I want to get it down as low as I can so that there's enough shank sticking out that I can work out the connection to the router collet. So this will go on here once I turn it all down, and it looks like that thread does come kind of close. So we'll turn that all the way down to as far as we can, and then we'll press this onto here, and then we'll try to press this. I'm not a very good machinist yet, so we'll see if that even works. If I can't press it on, I'll thread that shaft and I'll put a nut on it, I think, if I have to. So that'll go on there like that. And you saw that in the drawing. And then we'll also make a couple of things. So we've got our little slitting saws here. I have 5 of them for now. We'll bring in more if I can. If this works out, we'll bring in. So there's a 5/8 inch diameter bore. And there's also it's also keyed. But I don't have an easy way to make a key slot, and I don't have an easy way to make. Well, it's a capabilities thing. I don't know how to make a shaft with a keyed shaft, with the machinery and the tooling that I have. I'm going to do the friction and pray and see if it works. If it doesn't, I will find a way to make a shaft with a key on it. I may just take it to someone who can put a key in. We'll see. For now, we're going to try it with just friction. So we're going to make these blade bushings that will be as large in diameter as I can, because the fret slots only need to be at most 3/16 of an inch deep. I don't even think they ever go that deep. So maybe 30 thou, 40 thou, maybe a little more. I don't know, 60 thou, maybe. 100 is way too deep, way too deep. So it's less than 1/8 probably. Anyway, so we're going to hold this. We'll be between two. We're going to hold this between two. We'll call them. I don't know what to call them. They're going to be like stabilizers, but they're actually slitting saw holders. Basically, it's going to have a. Well, let me say what I have. I have a set of bearings that have 16 millimeter holes, or sorry, 15 millimeter hole going through them, and so that's a little bit smaller than 5/8 already, or sorry, yeah, that's a little bit smaller than 5/8, barely smaller than 5/8. And I also have a small collection of these. Well, I should open the other end, but we'll pull one out here. Small collection of 1/2 inch nuts. They're a fine thread and thin, low profile jam nuts. Basically wanted to keep the spindle length as low as possible. So there's going to need to be a fair number of levels. While the other thing is, I didn't have a die, and I could have turned the thread single point, but I wanted to get threads right up against the shoulder. and a die was easier for me. So I got these half-inch, they're half-inch, I think they're 20 TPI threads. So that'll be what basically holds my spindle on, and we'll show you this here. This is the drawing of my spindle arbor, or the arbor that I'm going to turn, which will be what I'll call the spindle from now on. And then this is that finished turning of, it's a bit zoomed out so I can, or zoomed in so I can read the measurements. This is the bevel gear. We're going to basically turn it to this shape. We're basically going to leave this end and some of this machined. These two machined surfaces will stay. The rest of this we'll try to turn down. I don't think I'm going to get to 10 millimeter on this point, but that's okay. We should have enough. So that's that piece. Then for the blade, it's going to get sandwiched between these two guys. And so we have, I should take out, we have this outer diameter. This OD here is 5/8, which matches our arbor, or our bore on our slitting saws. So the 5/8 bore on the saw will put the, you'll get a saw will go in on here. There's also a bore here, and this is nominal at the moment. I'll turn them to be a very tight slip fit, as snug as I can get so I can keep as good of a fit there. But the idea is that this length goes inside of this part, and the saw gets sandwiched by that. And what I will probably do is undercut this just a little and undercut this just a little so that we get good contact way out here. I'm not quite sure on that. May not. May leave them parallel. And then the inner bore for both through holes are 1/2 inch. So that'll get us our spindle shaft. And this is the area we're talking about. These two parts will go on here, into this space. So there'll be this. I guess we'll go to the spindle size. So there's the big gear here. We're going to see this ledge here and then this thicker zone. Well, I don't have a way to key anything, right? Oh, you can't see anything because I'm in the wrong, I'm not even in the shop. There we go. So this has 4 keys. It's meant to go on a keyed shaft. I don't have an easy way, and I don't know how to key anything yet. So what I'm going to do is I'm going to turn to this OD, or this ID, turn an OD to this ID, and that'll slide on, and I'll make it as snug as I can. And then there's this little ridge here. What I'm going to do is I'm going to put this in the lathe, holding it like this. I'm going to turn this edge to this surface. So I've got a good wide, probably more than 1/4 inch of surface here that I can drill and tap. A pretty good thickness too, so I can drill and tap this for some set screws. And I'll probably do 2 opposing, or I may do 3. Not quite sure on that. Maybe I'll do 4. Don't know. So that'll be a plan there. Is we'll put some set screws there, so that way it'll go onto this spindle, just like this. And I've left myself a lot of meat here because I want to make sure I have room to get this gear to align really nicely. So I've given myself room there, and if it turns out I need to reverse it, I'll have room to do so. I probably won't. This is all just an experiment. We'll see if it works out. So that's the large diameter of the spindle, of the arbor spindle. Then you got these two here, which are the bearing journals for these 15 millimeter bearings. The ID of these bearings is 15 millimeters, and there's plenty of room here, and this allows me to push the spindle around a little bit if I need to. It also gives me some clearance for the structure that the bearings are going to get pressed into. So there'll be a nut on this end, of course. So basically the idea is I've turned down to a 1/2 inch for these, and 15 millimeters for these, and about 30 millimeters for this to press nicely. This one won't press, this will slip on. But the bearing journals I'll be as close to a press fit as I can get them. So then those are those areas. That's the easy stuff. The other bit is this area. So what you'll have is you'll have a bearing here, and there'll be a 1/2 inch plate that the bearing goes into, and an 1/8 inch lip sticking out. So basically we're going to have a nut here that pushes the bearing against that, and a nut here that pushes the bearing against that. These have a small amount of thrust that they can handle, these bearings. And that should be enough to get this running freely and not allow for any shifting in the arbor. Then we'll have this item, this little guy here, which is, I'm not sure what to call this. It's part blade stabilizer and part, it's kind of a stiffener and a holder at the same time. So this will go here against this nut. I'll turn this nut to be a nice concentric with a washer face, and then this will go on there, and then the blade will go in there, and then this will come in and capture the blade, and then there'll be another nut here to push on there. So all of this will be a sandwich right in here. This way I've got about, I was talking about being able to use different size blades before. This allows me to use a blade that's 23 thou or thinner. It gives me up to almost a 1/4 inch. I wouldn't go quite past quite up to a 1/4 inch in width, and this machine's not going to be able to spin a 1/4 inch anyway, so it would bog down probably. We'll see. I'm suspecting that over 1/8 is going to be taxing, but we'll find out. Could be all right with all the gearing down that we're going to have anyways. But so that's the general plan for that. So today, what I'm going to do, at least to get this project started, is I'm going to do this machining, and I'm going to turn this thing down, because those are easy things. These two are existing, right? So this and this are going to be made out of some material that I've been trying to get my hands on for years now, and I just been cheap and didn't have a project until this came along. So the steel, I'm going to use steel for these things, and the steel I'm going to use is, I've never used it before. Some of you might notice it, and you might be able to read it there on the surface, is 12L14 steel. It's an alloy that is a steel with lead in it, and adding the lead makes the machinability super easy, apparently. And on my little tiny metal lathe, all the machinability advantage I can get, the better. But you'll see I've got this. This is 3/4, and it would do all but this bit. And this is where my severely amateur machinist Swiss cheese knowledge kicks in. Serious lack of knowledge, I should say. I don't know that I'm going to be successful at press fitting, but I've also got this 1.5" stuff, right? So if it turns out that I can't press, I will have enough material to play around with to make this entire arbor out of this. But from a material waste standpoint, there's an awful lot cut away here. So I'd like to avoid having to cut all that off from 1.5" stock. If I can press it, I will also pin it. I would probably put 2 or 3 cross pins into this as well, just to guarantee that, because all the torque's going to be on this outer bit by this gear. So that's pretty much the very long-winded intro to getting started with this. So let's move the camera and let's go play around on the lathe and cut some of this stuff. I'm going to take this. There's a little ridge there that changes diameter here. We're going to flatten this off so I have a good surface for some set screws. So we'll start with that. Now, how are you? You're pretty good concentricity. We're going to just set here and go for some facing style cuts in this. So we'll begin. Is just to do some drilling and tapping for a couple of set screws. And I don't know what this steel is, so we're going to take it gingerly at first. We're not quite dialed in there, but it doesn't matter. This is not a critical surface. Luckily, it turns really well. I'll call that one done. This one gives me my my flat, nice wide surface, and it's deep enough to get some good threads in. So I'll tap this for some set screws. So our plans say 10 millimeters is what we're shooting for. We're going to leave ourselves. I'm mixing dimensions like crazy. This is going to be great for people who love or hate either one. We're going to leave a 1/4 inch of whatever this is right here. That's just going to act as a shoulder to push against the bearing, and a spacer. Then we're going to turn this out here to 10 millimeter. So we're going to go to 10 millimeter as far as we can, leaving a 1/4 inch or something. It doesn't have to be too exact. Alright, so we have a pretty dang near pressed fit here. This is the bearing's on there already. We're going to push it up against this little fillet here, this little stop, I guess, this little shoulder. Finish is pretty decent. It's not bad steel. So what I'll do is I'll press this on here, and then we'll go about the next bit of our task. Alright, so we pushed that up under the shoulder. It was a brutal task, I will assure you. I am not a Tom Lipton or Keith Fenner or Adam Booth or James Kilroy or Keith Rucker or whoever, all those guys I watch. I don't have a press, so I kind of cheated and did it the old mallet and tube way. So brutal, but it's on there and it's running really smooth and quiet and nice, so it should be good. So now all we got to do is press this into our piece of aluminum as the top, and the bearing will be pressed into that, and then figure out a way to grab this and get it into the router. It's smaller than a 1/2 inch, so I might be able to just bore out a 1/2 inch drill rod and just put a sleeve here and somehow grab a hold of it or something like that. We'll figure out a way. So that's this part.